Hello, this is part 2 for today. We are finding probabilities, and our goal for today is to use a tree diagram to find probabilities. You learned how to make a tree diagram in the last video, and now we're doing the next step. A few things about probability. Fundamentally, it's the outcomes you want over all possible outcomes. So a great example of this would be flipping a coin. You might say, what is the chance of getting heads? Well, there's two sides, heads and tails, so that's all possible outcomes. What do you want? Just heads, so 1 over 2. Another detail, I want you to label your answer with words. Probabilities a lot of times are just numbers, and we want to make sure our work is clear. So you want to label your numbers with words. And then finally, you may write your answer as a fraction or a decimal to 3 places. So for example, if you get 1 out of 6, or as a decimal 0.167. As a general rule, we do not care which way you write your answer, whether you prefer a fraction or a decimal, but you should be comfortable with both. So, in the last video, we had this ice cream menu where we had to pick a cone, kind of a cup style cone or a pointy cone. We had to pick a flavor, chocolate or vanilla for the ice cream, and we had to pick a topping, strawberry sauce, chocolate sauce, or peanuts. And so from that, we were able to make the following tree diagram. And from that tree diagram, we ended up with 12 possible outcomes. And so now we're going to use this to answer some probability questions. Our first question, probability of picking vanilla ice cream. So all we got to do is look at our 12 possible outcomes and see which ones have vanilla ice cream. And we can go down our list and see in fact that there are 6 ice creams with vanilla, six ice creams with vanilla ice cream. So I'm writing my answer right here, capital P parentheses vanilla ice cream. This right here is a shorthand, and that capital P in parentheses is read probability of. So this statement right here is saying probability of vanilla ice cream. And now my work is very clear. So what is my probability? I have 6 vanilla ice creams out of 12 total. So 6 out of 12 or 0.500. If you wrote it as 0.5, totally okay. So let's go on to the second question. I encourage you at any point to pause these and try them on your own. It says probability of getting chocolate. So right away we can start from the get-go and we can recognize our 6 chocolate ice creams. But we need to be careful because it doesn't say chocolate ice cream, it says chocolate. So what about this outcome right here where we end up with chocolate sauce? Well, that counts. And so we've also got this one down here as well. And so we don't have just 6, but we really have 8 times where we end up with chocolate. So our probability of chocolate is equal to 8 out of 12, or written as a decimal, 0.667. Going on to question 3, probability of a bowl, the bowl cone, if you will, or nuts. So same thing up here. We've got all of these choices up here that have the bowl in them. And we've also got these 2 choices down here that have the cone. And here's what you need to be careful with on this one. The or statement means that only one part of it needs to be true. If I have a bowl, I count. If I have nuts, I count. As long as one condition is met, it counts towards what I want. So probability of bowl or nuts is going to be our total over here, which again is 8 over 12, or 0.667. Going to go on to question 4. I changed one word, and now it's probability of a bowl and nuts. So here's what I want you to think about for a second. If I have to be in a bowl and have nuts, this first choice up here, I've got the bowl, but I don't have nuts. So guess what? It doesn't count. it does not meet our condition. Second one right here. I've got a bowl, no nuts, doesn't count. Now this one has both the bowl and the nuts, so it's good. But as we go down our list, we can get rid of the ones that don't have a bowl and don't have nuts. And we're only left with two possible choices. So our probability of a bowl and nuts is going to be 2 out of 12 or 0.167. Small comment, anytime you get an and statement, the numbers tend to get smaller because it's more specific. You have to meet both requirements. And then lastly, question 5, probability of caramel or caramel, depending on your approach. Well, let's think about it. Do any of these have caramel in them? And you might be shaking your head saying no. Well, that can happen in probability. So what's my probability of getting caramel? 0. There are no possible outcomes that have caramel in them. And so our decimal would just be 0 as well. So with those examples, hopefully you have a basic idea of how we can use a tree diagram to find probabilities.